How can we make a forecast when we have seasonal data? A seasonal dataset is the dataset that repeats a certain pattern. When our dataset shows a seasonal pattern, we can use something called the seasonal factors. Seasonal factors are called seasonal indices. A seasonal factor is a value that indicates the level of demand relative to the average demand. A seasonal factor for a particular season can be defined as follows. It's the average demand in that particular season over the overall average demand. So for example, if a seasonal factor of 1.2 for April implies that April's demand is 20% greater than the average monthly demand. Let's take another example. A seasonal factor of 0.7 for August implies August demand is 30% less than the average monthly demand. So let's take an example. I want to show you how to use seasonal factors to make a forecast. The manager of the Stanley Steamer Carpet Cleaning Company needs a quarterly forecast of the number of customers expected next year. The carpet cleaning business is seasonal with a peak in the third quarter and a trough in the first quarter. The manager wants to forecast customer demand for each quarter of year 4 based on an estimate of total year 4 demand of 2,200 customers. So this is our data set. In the first year, we had 46 customers in quarter 1, 335 in quarter 2, 520 in quarter 3, and 100 in quarter 4. And this pattern is repeated every year. Now we are at the end of year 3, and we want to make a forecast for next year, year 4, and each quarter of year 4. So what steps should you follow? First, identify the pattern of your dataset. So let's plot this on the XY plane. So the x-axis is the time from the first quarter of year 1 to the last quarter of year 3, and the y-axis is demand, and it looks like there is a repeated pattern. So this data set is seasonal. So since you have a seasonal data set, you need to find the seasonal factors. How many seasons do we have every year? How many data points do we have in each cycle? This is the first cycle, this is the second cycle, this is the third cycle, and we have 4 values in each cycle. And the number of values in each cycle is called the periodicity. So the periodicity of this example is 4, and we need to find 4 seasonal factors. So how would you compute the seasonal factor for quarter 1? So it's defined by the average quarterly demand in quarter 1 over the average quarterly demand. So this ratio will tell you how much the demand in quarter 1 is inflated or deflated because of the seasonal effect. So how would you compute the numerator? The average quarterly demand in quarter 1, how many data points do we have in the first quarter? So we have the first quarter of year 1, the first quarter of year 2, and the first quarter of year 3. So we have 3 values, so we need to compute them. 46 plus 70 plus 100 divided by 3. That's equal to 72. Next, let's go to the denominator, the average quarterly demand. So in total, how many data points do we have? We have 12 data points, so we can compute the average of these. So add all of these numbers, 30, 135, 20, 100, and then second year, 70, 370, all the way up to year 3 and divide it by 12, and you get 334. That's the overall average quarterly demand. So we computed the average demand in the first quarter, and we computed the average quarterly demand, which was the sum of all the demands divided by 12. And what's the seasonal factor? It's the each quarter's historical average demand over the average quarterly demand. So for the first quarter, it's the average demand in the first quarter divided by the average quarterly demand. So that's equal to 0.22. And we can repeat this for the second quarter. How would you compute the seasonal factor for quarter 2? Again, this is the average demand in quarter 2 over the average quarterly demand. How would you compute the numerator? So how many data points do we have for the second quarter? 3. So compute the average of these 3 and add them up, divided by 3, you get 430. So that's the numerator. What's the denominator? That's the average of all 12 values. So add them up, divided by 12, you get 334. So you take 430 divided by 334, you get 1.29. And you can repeat this for the rest of the quarters, for quarter 3 and quarter 4. Now let's talk about the meaning of a seasonal factor. In the previous example, the seasonal factor for quarter 1 turned out to be 0.22. So what's the meaning of this? It's the seasonal factor is the ratio of the average demand in the first quarter to the average quarterly demand, and it was 0.22, which means 22 out of 100. In other words, if the average quarterly demand is 100, then the average demand in the first quarter is only 22 because of the seasonal factor, because this is the first quarter. So if the average demand average quarterly demand is 100%, the average demand in quarter 1 is only 22%, which is 78% less than the average quarterly demand. So how can we compute 78? Take 100% minus 22, which was the seasonal factor for quarter 1. Let's take another example. The seasonal factor for quarter 2 was 1.29, and it was the ratio of the average demand in quarter 2 to the average quarterly demand. And 1.2829 is the same as 129 over 100. So that means if the average quarterly demand is 100%, the average demand in the second quarter is 129%. And that happens because this is the second quarter. So in other words, if the average quarterly demand is 100%, the average demand in quarter 2 is 129%, which is 29% greater than the average quarterly demand. So how can you compute 29%? Take the seasonal factor, 129% minus 100. So let's go back to our previous example. Now we already computed the seasonal factors. Now the manager wants to forecast customer demand for each quarter of year 4 based on an estimate of the total year 4 demand of 2,200 customers. That means we are expecting 2,200 customers throughout the year, next year. So given this information, how can you make quarterly forecast? First, let's distribute the annual forecast evenly across all the quarters. The annual forecast was 2,200. We have 4 quarters, so divided by 4, that's equal to 550. So this is what we would expect if there is no seasonal effect. But there is seasonal effect, and the seasonal factors tell us that the actual demand gets inflated or deflated because of the seasonal effect. So for example, the seasonal factor for quarter one was 0.22. And what does this mean? The demand, this was the ratio of demand in quarter one over the average quarterly demand. Now, if we multiply each side by the quarterly demand, the left-hand side is 0.22 times the quarterly demand, and the right-hand side becomes demand in the first quarter. So that means demand in the first quarter is the quarterly demand, average quarterly demand times 0.22. So the seasonally adjusted forecast is this average quarterly demand times the seasonal factor for this quarter, which is 0.22. So that's equal to 121. And again, for the next quarter, the seasonally adjusted forecast is 550 times the seasonal factor, 1.29, which is 710. And we can repeat this for the rest of the quarters. So here are the steps to follow. Find the average historical demand each season, and compute the average demand over all seasons. And number 3, compute the seasonal factor for each season by dividing that season's historical average demand by the average demand over all seasons. Number 4, estimate next year's total annual demand. Number 5, divide this estimate by the number of seasons, then multiply by the seasonal factor for each season, and that's the seasonal forecast.